again with the PC application, and I'm going to explain a little bit about the addressing system on the MK14. Well, some address spaces are duplicates of each other. I call them mirrors. Now if I click on this space here, you can see the contents of the entire memory all the way up to FFFF, which is the maximum the MK14 address space goes to, all the way from 0. The first two 256 blocks take up these spaces here in ROM, which is within this memory space, and the last byte there is 1FF. Now if I load in a program, let's just say it's a simple let's see what we got, just a clock or something like this. Open up the clock program, and we will see that the address space is taken up from F12, which is the data bytes for the clock, and it will start at F20 as per the manual, and it's only taken up half the space. If I click this once again, at the moment you'll see there's nothing here. If I click this once again, it'll refresh the memory space, and you'll see F20, this is the program which is loaded into memory here. It took up about half of the available memory for the standard RAM. And there's no mirrors, there's no duplicates of that information. Now, will this run? I don't know. Let's try it. F20 run. Yes, there you go, there's the clock. It runs. Now, if I run at 1, it should run the monitor. Here you go. 0, F2, 0. I'm pressing the keys on the keyboard now, using these keys here. F2, 0. You see the first byte is C4. If then I go along and look at the next key, M, which is the mem key, see the next space here, 0, 1, which corresponds to this space. The next one should be 37 if I press M again. So this is the monitor now running, and there's no duplicates in the memory space here. One thing you'll find is that it also picks up on the data spaces here from the monitor and from the clock program itself, which is these few bytes here, which will be located in this space here. So if I do a refresh just now by clicking this space, you'll now see that the F100 now has other bytes in it, because the monitor itself, displaying the keyboard, scanning the keypad, these sorts of things are in the first few bytes here, and the clock itself has a few of the bytes used here. So this is a nice way of debugging any sort of programs which might be saving bytes and using up memory in that sort of way. If I pause this, load a different program in. Now, the one thing I want to show is that at 800 is the I/O space. So the I/O chip, which complements the processor, gives all of the quite a lot of ports, bits, sets which go after the edge connector. But it's also got 128 bytes of RAM built in. At halfway through the space is 880, and this will be the RAM space here. So if I was to load a program which used this space, the effect of the MK14 is to duplicate this at repeated locations towards the end of the address space. Let's have a go if I load a program, and the one I like to use is my good old Defender, and 14, there you go, and that's loaded in now. Now it's loaded in overlapping spaces. It's at starts at A80. We'll see there's going to be a mirror of that, and it concatenates nicely with B0 here. So we can have a contiguous memory space and have a larger program running at A80. Now it's not shown yet. I need to refresh this by clicking this space. You might have seen some mirrors shooting past. If I go to 880, here is the first 128 bytes of the Defender program. Nothing at 900 because that's not repeated. 880, and then we keep going and we see it at A80, and that concatenates with the B0 here. If I keep going down the memory space, C80, there's another mirror. The D space is for this 7-segment display, and that's not a mirror of the other spaces. E80 is another mirror. So that was 4 locations for the I/O RAM. So this little box displays that quite nicely. If the program itself that you'd written writes to one of those spaces, and then you refresh this space here, you will find that the mirrors do actually occur. So this is all taken into account in this PC application. And let's just run this for the sake of it. A80. Let's run it. Sorry, I need to turn on the video. And then run it. And here's our Defender program. If I press the number 3, this makes the Defender go up. If I press D, I think, yes, it's supposed to fire. You don't always see it on this screen. It's shooting, trying to shoot the spaceship now because it's online with the spaceship. And then when I press D, I'll try to get online again. As Defender falls, I'll press D. I'm pressing D, and you'll see the score is going up. I'm hitting things, not necessarily a spaceship, but you can see it more clearly on the real unit and with the VDU fitted. So it's all well and good.